Now we are going to learn about Pythagoras theorem. So Pythagoras theorem, let's first see the statement of this theorem. Now, the statement of the theorem is, in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. I repeat, in a right-angled triangle. So it is basically concerned with the right-angled triangle. The square of the hypotenuse is equal to the sum of the squares of the other two sides. So I'm going to prove this theorem using two methods. One is the activity method and the other is our analytical method, which you need during your examination, which is to be written during your examination. So let us start with the activity method. So let's take a right angle triangle of size length 3 centimeter, 4 centimeter, 5 centimeter. Okay. And prove the above theorem by activity method. It's a simple method using graph paper. We need a graph paper, okay, a scissor, gum. So let's begin by drawing a right triangle as shown. A measurement may not be to the scale, but the concept and the method is important. Now see, proof of the theorem by activity method. I have drawn a triangle which is 4 centimeter long, the base length is 3 centimeter and the hypotenuse is 5 centimeter. Okay, I've drawn it a little big enough so that it is quite clear. Now what you need to do is take a paper, draw a triangle of this size 4 centimeter by 3 centimeter by 5 centimeter, cut it and keep it, okay, and paste it on a sheet. Then on this side, so take a graph paper, take a size of 4 centimeter by 4 centimeter. That means you need to cut a graph of length 4 centimeter, width also 4 centimeter. Make a square of 4 by 4 centimeter. Okay, and paste it alongside AB. Along the side AB side, you just paste that graph paper which you have cut and this. So it will look like this. So 4 centimeter by 4 centimeter. Okay, paste it along the side AB. Next, what you do is you take again your graph paper. Now this side BC is of length 3 centimeter. So cut a graph paper of side 3 by 3. Okay, and paste it here. So it will be here like this. Paste it when you paste it here, it will be 3 centimeters by 3 centimeters. So you are finished with AB side and BC side. Now find the length of AC. What is the length of AC? AC is 5 centimeter. Take your graph paper again, cut 5 centimeter by 5 centimeter and paste it along the side AC. So when you paste it, it will look like this. So you have pasted all the three sides. Now, the proof of the theorem, what is it? Now you see, start counting the number of squares on this side of AB. How many is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 squares here. Here if you count, say 3, 6, 9. There are 9 squares here. Here 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There are 25 squares here. So this side we have got 16 squares. Here we have got 9 squares and here we have got 25 squares. So let us make a note of that. See, here you have got 16 squares. Here you have got 9 squares. Here you have got 25 squares. This 16. 16 is what? It is the square of 4. 4 square is 16. 9. 9 is the square of 3. 3 square is 9. And 25 is the square of 5. 5 square is 25. Okay. So that means now if you see this, see this is 16 squares. Let's add these two. You will get it is equal to this. 16 squares plus 9 square is 25 square. 16 square means what I said? I said it is 4 square. 9 square means 3 square. And 25 square is 5 square. So 16 plus 9 is equal to 25. So now what we have taken, so let us take the side AB as A. BC has B and AC has C. So this is A square is, so 4 AB we have taken, 4 was AB side, that is A square, and 3 is, this is BC, so I have taken this as B square, and this length has taken as C square, C square. So you know that this is a perpendicular, so you can say it is a perpendicular square, plus this is the base of the triangle, so it is a base square, and is equal to this side, that is 25 square, that is a hypotenuse. So it is hypotenuse square. So perpendicular square plus base square is equal to the hypotenuse square. This is your Pythagoras theorem. So we are able to prove this theorem using the activity method. So you can do this and see for yourself. So you are just somebody in a lower classes, you have been told the theorem and just you keep on missing. Now in this class, that is in 10th standard, I'm trying to teach you that how this has been derived, okay, by activity method. Now this was an activity method, so you can do this as an activity method to confirm that whatever Pythagoras had said, it is really true. You can try it for different triangles and use the same method, you will get the same result. Okay, so that is how the proof of the theorem is. But in an examination, okay, so I have written here, see, this is A, this is B, this side is B, and this is C. So A square plus B square is equal to C square. Now, however, in an examination, they expect you to write the analytical method, which is written in your textbooks. So they will tell you prove this theorem. So in order to prove that theorem, we need the analytical method. So make a note of the analytical method, which is, and you have to learn it by heart because this proof has been asked every year. You must know the proof of this theorem. The board expects you to know the proof of the theorem. So if you can has a conclusion, so perpendicular square plus base square is equal to hypotenuse square. This is the Pythagoras theorem. Now let us go to the analytical proof. Question is usually asked as state and prove the Pythagoras theorem. It's a simple statement. So there you will have to write the whole thing. Or the statement is written and they say prove that. Prove that in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Square, prove that. So when the word prove that is there, and this is the statement of the theorem. Okay. So you must, the moment you read that, you must know that he is asking you to prove the Pythagoras theorem. Okay. So one, they'll simply write prove that and write the whole statement. So you should know that means what happens. They expect you to know the statement thoroughly so that the moment you read it, you get a clear idea that yes, we have to prove Pythagoras theorem. Now, before we get into the proof, we just need to see a few points, that is instructions while writing the proof of the theorem. Proof of any theorem must have the following headings. Mind well, make it a note that you must have these headings, because marks are allotted for each heading. There is a possibility of losing marks if one or more of the heading is missing. Also, if you don't know the proof of the theorem, at least write the heading up to the proofs, you will get some marks instead of no marks for the question. The headings are statement of the theorem. Statement of the theorem is given in the question. So you just write statement and copy the question part of it. You will be able to write the first heading. Then draw the figure. You know, you will have an idea how this figure, because Pythagoras theorem, you should remember that it is always concerned with the right angle triangle. You draw a right angle triangle and keep it. Then given. Again, you know, Pythagoras theorem, it's right angle triangle must be given. So just write what is given. Given is given a right angle triangle, right angled at B, or some whichever side you expect. So that you can write. Then what you have to prove? Then prove that hypotenuse square is equal to perpendicular square plus base square. So that also you can write. Then construction, if any. That means some figures we need to little modify the figure in order to prove it. In some, it's whatever is there. So here in this theorem, you need to draw one perpendicular. Okay, and just write this. So you write these 4 steps also. Instead of getting no marks, they will give at least 1 mark for the whole question, because if the question is for 5 marks or 4 marks, definitely you'll get 1 mark if you have written all these 4 steps. Okay. So what is our suggestion is never leave any question unattempted. Write something and come back, so that at least something you will get instead of getting 0. Okay, make it a point. Now let's see the problem. So first, you have to write a statement and underline that. So the examiner will know for sure that yes, you are writing the statement here. In a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other 2 sides. So this statement you have to learn it by heart. Having written the statement, then draw the figure. So this is your figure. Okay. So what is this figure? What is given? It is given a right angle triangle ABC is given, in which angle B is 90. That means I have drawn this angle as 90 degrees. Okay. Now what I have to prove? Hypotenuse square is equal to base square plus perpendicular square. So in this right angle is here, the side opposite is the hypotenuse. That means this is the hypotenuse. So that is AC square is equal to AB square plus BC square. AC square is equal to AB square plus BC square. Now, this is only a triangle is given. In order to prove this, what you have to draw, make some construction. There's a slight modification in the figure. That is, from B, draw BD perpendicular to AC. From this point B, draw BD perpendicular to AC. So here I am put a perpendicular mark, that is 90 degrees. So that means this line segment is perpendicular to AC. Okay. So this is the 4 headings which is. Now after the construction, now you know that is a proof. So see, this is a triangle here. First I am taking this triangle triangle, that's ADB and AB full triangle. So see this. In triangle ADB and ABC, in this side triangle and the complete triangle, ADB is equal to ABC is equal to 90. That means this angle is 90 and this angle is also 90. So ADB and ABC is both 90 degrees. Now see this angle. Angle A is a part of this side triangle and angle is a part of the full triangle also. So angle A is equal to angle A. It's a common angle. So these two angles are equal. These two angles are equal. So by AA similarity criteria, we say that triangle ADB is similar to triangle ABC. If these two triangles are similar, then ratio of the corresponding sides must be equal. So that means I take this base side and the hypotenuse of this small triangle. Base is AD, hypotenuse is AB. So I write AD upon AB must be equal to, when I take the full triangle, so base is here, I take AB as a base and hypotenuse is AC, because for the bigger triangle, that is triangle ABC, hypotenuse is AC. So AD upon AB is equal to AB upon AC. Now you see here, there is an AB here, there is AB here. So let's cross multiply it. AB into AB is AB square is equal to AD into AC. So AB square is equal to AD into AC. This is your first equation. Okay. So this number equation as 1. Now let us take this side triangle and the complete triangle again. That is, and triangle BDC and triangle ABC. When you take these two triangles, again, here this angle is 90. That is, CDB is 90 and angle ABC is also 90. Both are 90. So, angle CDB is equal to angle ABC is equal to 90 degrees. And now this angle C is a common angle to both this triangle. It's a part of this side triangle and it's a part of the full triangle also. So angle C is equal to angle C. It's a common angle. So By AA similarity criteria, these two triangles, that is this triangle, this side triangle, and this complete triangle, both are similar. So when these two triangles are similar, when I take this side B base as DC and hypotenuse is BC. So DC upon BC is that ratio must be equal to when you take the full triangle. So BC upon AC, BC upon AC. Now again, so DC upon BC is equal to BC upon AC. Cross multiply it. BC into BC is BC square is equal to BC into AC. This is your equation 2. So this is your first equation. This is your second equation. Now we need to add these two equations. Add equation 1 and equation 2. Now just see AB square is equal to AD into. So when you write adding AB square plus BC square is equal to this plus this. So let us see how it is written. Adding equation 1 and 2 we get AB square plus BC square is equal to AD into AC plus DC into AC. You see this side, AC is here, AC is here. So let us take out AC common. When you take out AC common, here you are left with AD, write that AD. In between there's a plus sign, write that plus sign. AC is already outside, so DC is written. So AC into AD plus DC. AD plus DC, you see again the figure, AD plus DC. When you add this to this part and this part, you get the whole length AC. So AD plus AC is equal to AC. So this is now AC and this total is also AC. So AC into AC is AC square. So AB square plus BC square is equal to AC square. Hence you can say AC square is equal to AB square plus BC square. AC is the hypotenuse, AB is the perpendicular, BC is the base. So you are getting AC square is equal to AB square plus BC square. So this is the proof of the Pythagoras theorem. We have already learned in lower class A square plus B square is equal to C square. Same thing. Okay. So this is the proof of it. This proof you are supposed to know completely by hand. But see, make a note of this proof. See that you learn it, and it's not very difficult. You see, very simple proof it is. So learn this problem. This is what they expect you to learn right during the examination, and they tell you to the Pythagoras. Now we see what is the converse of the Pythagoras. The reverse of what we say is here the result of the Pythagoras theorem is used to prove that the triangle is a right triangle. The converse is what we have said in while proving the Pythagoras theorem. We have taken that triangle is a right angle triangle, and we proved it is equal to the hypotenuse square is equal to perpendicular square plus base square. Now in converse what we are doing, we take the result of the Pythagoras theorem and prove that it's a right angle triangle. Okay. So here there's a little confuse. See this, I have written something, just read this. Students often confuse themselves with the proof of the Pythagoras theorem and its converse. So when they are writing so people are, your usual students are in a hurry. They see the word, letter for Pythagoras, they immediately start writing the proof of the theorem. Sometimes it is, they ask you the converse and you without reading the thing, you write the proof of the theorem and you lose marks completely. So read the statement of both the theorems carefully and note the difference. So that when you read the statement, you must be able to differentiate whether they have asked you to write the proof of the Pythagoras theorem or they asked you to prove the converse of the Pythagoras theorem. So by reading the statement, you must be able to decide exactly what they want. Because why this is important is, see, we know that CBSE issues 3 sets of question papers. So set A, set B, set C. So your friend sitting in front of you must be writing the proof of the Pythagoras theorem because that is asked in his question paper. You also start writing the proof of the Pythagoras theorem. But in your set, the converse is asked. I have seen many my students making this mistake. So that's why this I say first, before I start proving this theorem, I just say you have given this word of caution. Please be careful. Otherwise, you see that your friend is doing and you also start doing it and could be a big blunder. So make sure that you read the statement and understand and clearly know whether they want you to write the Pythagoras theorem or the proof of the converse of the Pythagoras. Now let us come to the statement. Statement of converse of Pythagoras theorem. In a triangle, if the square of one side is equal to the sum of the squares of the other two sides, that means square of this side is equal to sum of the squares of the other two sides, then the angle opposite the side is a right angle. That means angle opposite this side, that is this angle, is a right angle. That is a converse. So read the statement carefully. So in a triangle, if the square of one side is equal to the sum of the squares of the other two sides, then the angle opposite to the side is a right angle. If this is opposite the side, then it is the converse of the state. Prove Pythagoras theorem, which he wants you to prove. Okay. Now, what is given? Only one triangle is given. We are given a triangle ABC where AC square is equal to AB square plus BC square. This is what is given. We are starting with the Pythagoras theorem and proving it's the right triangle. So this is what is given. What you have to prove? You have to prove that angle B is 90 degrees. That is, triangle ABC is the right triangle. Now we have to prove that, we construct another triangle. We construct a triangle DEF. How do we construct it? We construct this triangle taking DE, length of DE equal to length of AB. Length of DE equal to length of AB. Length of BC equal to length of EF. And I draw angle E as 90 degrees. I draw this angle 90 degrees. If this is 90 degrees, then you apply Pythagoras theorem to this triangle. So here the hypotenuse is DF. So DF square must be equal to DE square plus EF square. So let's see the proof. Proof is, to prove that angle B is 90, it is sufficient to show that these two triangles are similar, that the triangle which we have drawn and the triangle which we have been given, both are similar. We need to prove these two triangles similar. So since triangle DEF is a right angle triangle with a right angle at E, therefore by Pythagoras theorem, we have DF square is equal to DE square plus EF square. But how did I construct? When I constructed it, I have taken DE is equal to AB. So instead of DE, I can replace it with AB square. And I have drawn EF equal to BC. So I can replace EF with BC and write BC square. So AB square plus BC square. But AB square plus BC square is given that it is equal to AC square. So DF square is equal to AC square. Take the square root of both the sides, it will become DF is equal to AC. That means the third side is also equal. Now let us take the two triangles. That is again triangle ABC and triangle DEF. AB is equal to DE, which we have constructed. BC is equal to EF by construction. And AC is equal to DF because we have proved that. So that means these three sides of this triangle both are equal. Therefore, these two triangles are congruent. Because these two triangles are congruent, angle B must be equal to angle E. But angle E is equal to 90. That means angle B is also 90. So, therefore, triangle ABC is a right triangle, right angled at B. Okay. So that's how we prove the converse of the Pythagoras theorem. Here, this proof also. See, the proof is a very small proof. Okay. Could fetch you full 5 marks. So make sure that you don't write the Pythagoras theorem if a question is asked. So I think you have understood my explanation, and if you are very happy with the explanation, please do subscribe for this thing so that I'll be sending more and more notes on this syllabus chapters. Okay, so subscribe and press on the like link. So I would like to put a statement that if you liked my method of explanation and you want to be trained for class 10th class board examination, You can WhatsApp me at the number given with your name, place, school name. I usually charge rupees 30,000 for the entire course of 10 months. If you book now, I will offer it for rupees 20,000 for the entire course. Sooner you start, better your results. This is my number. Make a note of this and please put a message me on this number so that I'll be able to correspond with you. Okay. I usually conduct online classes for my students, so I'll be able to give you the updates about all the new question papers, what are the different types of question paper. So it will benefit you. Please give it a thought. So lastly, I would say that please click on the subscribe button and the like button. Okay, my channel is Easy Learning. I'll make learning very easy. Thank you for watching and stay tuned for us. You subscribe here, you will get an update of all the things. Okay, thank you.